Hi, my name is Sal Nacella. I teach technology education at Mashpee High School, and we put a presentation together. I have 5 students chosen that I chose from my drafting and animation classes, and each student that's attending today had a chance to go through the process of building a 3D model using CAD software. We're currently using Creo 2, and they go through the process of building, designing, reverse engineering different products and projects, and we go through after the projects are built, we create what's called a stereolithography file, and we eventually print it out.
This one is called 3D Animation 1 and 2. That one is Creo, which drafting, and we use Creo with that one. Basically, we make it on a program called Maya. It's a program from AutoDesk, and we basically start with simple shapes like a sphere or a square or pyramid, cone, things like that, and we can modify how many subdivisions are in it or how many vertices are in it, and manipulate it to shape it as like this foot. Like we could start off with a basic square and just extrude from different subdivisions to make the boot shapes, like all these little details, all these different types of things, and
basically working up from really simple like polygons to more complex ones.
We bring it to an STL, which is stereolithography, isn't it? And we basically the printer just prints it out for us. But we also have a program called Mudbox, which actually is, you can start off with a figure like say a T-Rex or a tree stump, and we can do whatever we want to it. And this, you can just basically, it's clay models and you can sculpt it, and I'm pretty sure that's what this one was made in, and you could just sculpt the different details that are all in the T-Rex. And these are all based off of video games. Like these are, well, this group is Mass Effect video game, Halo we have, Avatar the movie. Depending on the amount of detail that is in it, like this has a huge amount of detail in it, so this would take many hours, if not days, to print this out. Actually, it took 2 days to print this out. But to design, she took many weeks of many hours every day to make these objects. And
my process of making this model right here took around, I'd say, a period of 2 to 3 weeks, and I did rough passes over each time. I worked on very simple stuff like the cylinders first off, and working on with very simple cubes and just expanding that to create more complex shapes like the sleeves and the drill. And it took quite a while, and the final product looks really great, and I'm happy with it. But I do wish to be able to rig it soon and make it move, and with the human IK render, I believe. And yeah.
And we can animate these by putting joints in where actual human joints would be, and make them move like real human beings would move.
You can see from the work, the students that they're doing, a lot of the things, the college level work in animation. A lot of the students work to design and reverse engineer existing models and create their own, and we have a lot of things from the video game industry, some things from 3D animation, movies. We have a lot of students at the high school that are interested in going into game design when they graduate, and a lot of students have gone on to different schools that specialize in animation and gaming. And also on this side, we have a lot of mechanical engineering students interested in different types of design products. And this is strictly with Creo. A lot of this is reverse engineering techniques, reading blueprints, and going through the design process. So on this side too, we have also a lot of students interested in pursuing degrees in engineering. Mechanicals seems to be a specialty and interest of my students.
Okay, so to make these glasses, I started out with a base shape. I used a cube, and I basically made different planes, and I cut into the block to make the shape, and I cut out a hole for the lens, and I rounded the corners. And then I mirrored it, because I only made this half. I mirrored it over the other side. Then in a different part, in a different file, I made these, and I did the same thing with that. And then I assembled them in one program, and then it put it into an STL, and then printed from that.
I don't know if you want to talk about it or no. Yes, no.
Made your own case?
Yeah.
Wow. She's practical.
They're all great students.
So, to make this, I basically just went on Google and looked up a picture of an old cell phone, and then I started with a rectangle, started making cuts in it, patterned all those buttons on, and then drew in the numbers. That was really all I did.
But there's, a lot of them go through the process, and when they leave, they're very well prepared for going into the not necessarily the job market, but I've had some students go from high school to work summers at some of the different local technology places, Woods Hole and a few other businesses working in 3D, and a lot of students have gone on to mechanical go to mechanical engineering and designing schools when they graduate, and again, they're very well prepared, as you can see by the level of work that they do. We have a website, mashpeetech.com. You want to take a look. We have all the students' projects you'll see up there. So if you want to take a look at it. So the best thing to do is just go through the website, and again, it's a fairly detailed website, and it shows, like I said, our students' work, course descriptions, and different opportunities that are available at Mashpee High School.